All right, this is the review of Unit 2 from last year, Day 2. Homework for today's lesson is going to be page 10 in this packet. And let's go over the homework from the day 1 first. So we've got a square root equation, so we want to get the square root by itself. So we subtracted x on both sides. Then to undo the square root, we squared both sides. Now, the key thing is on the right side, you've got to write that out twice and FOIL it out. Okay, you cannot square them individually. Once you FOIL it all out, since we have an x squared on the right, we want to get everything over to the right side and combine like terms. That gives us the x squared minus 12x plus 32 you see at the top right. We want to multiply to 32 and add to negative 12. So that would give us x minus 8 and x minus 4. Set those each equal to 0 and we get 8 and 4. But you always have to check your answers in square root equations. If we put the 8 in for x, 2 times 8 is 16. Minus 7 will give us 9. Square root of 9 is 3. And then you got to do 3 plus your x value. So 3 plus 8 does not equal 5. So we reject that. If you put in the 4, 2 times 4 is 8. 8 minus 7 is 1. Square root of 1 is 1. And then 1 plus the x value of 4 does give us 5. So only the 4 works out. If by chance everything was rejected, then you would say no solution. In the second and third, do your menu number factor. We get 2 squared, 3 times 7. So we have a pair of 2's, put one out front. The others stay inside, 2 square root of 21. Menu number factor for 90, 2 times 3 times 3 times 5. You've got a set of 3's, or one of the 3's comes out. The 2 times 5 stays inside. You have 3 sets of x's, 1 from each comes out. 1x stays inside. 2 sets of y's, 1 from each comes out. So you have 3x cubed y squared, square root of 10x. Now we've got a cubed root. So to do menu number factor, we get 3 cubed times 5. So that's one set of 3 3's, so 1 3 comes out. The 5 stays inside. A set of 3 x's, 1 comes out, 1 stays inside. 2 sets of 3 y's, so 2 come out, 2 stay inside. So we get 3xy squared, cubed root of 5xy squared, choice 4. And the last one from the homework, subtract the 2 over and then divide both sides by negative 1. Then the radicals by itself, so square both sides. Again, you have to write it twice and FOIL it out. Once you get that, since the x squared is on the left, we'll move everything over to the left. Combine like terms. And then we want to multiply to negative 15 and add to negative 2. Numbers that will do that are negative 5 and 3. So we'll have x minus 5 and x plus 3. Set those each equal to 0, and you get 5 and negative 3. But then we have to check. So on the left, we'll have 5. Inside the radical, 2 times 5 is 10. 19 minus 10 is 9. Square root of 9 is 3. 2 minus 3 is negative 1, and that doesn't equal 5. So we reject the 5. If you do negative 3 times negative 2 is positive 6. 19 plus 6 is 25. Square root of 25 is 5. And 2 minus 3 gives us negative 3, which matches the x value over on the left. So negative 3 is a keeper. All right, so we're going to be on packet page 6. We're going to be working with imaginaries today. So first thing, we're going to multiply it out. We're going to FOIL it out. So the 5 times 2 will give us 10. 5 times 4i will give us 20i. Then 3i times 2 will give us 6i. And 3i times 4i, well, the 3 times 4 gives us 12, and I times I is I squared. The key thing to remember is that I squared is the same as negative 1. And if you're unsure of that, you can just do I, which is with the pi button. Do that squared, and your calculator will give you back to negative 1. So this becomes 10. 20i plus 6i gives us 26i. And negative 1 times 12 gives us negative 12. Well, the 10 minus the 12 gives us negative 2. plus 26i. And that would be in what's called simplest a plus bi form, where you do the real part first and the imaginary part second. With the next one, we'll do the same thing. Negative 2 times 3 will give us negative 6. Negative 2 times negative I will give us a positive 2i. Negative 2 times 3 will give us, oh, sorry, not negative 2 times 3. We got to do 5i times 3. That'll give us 15i. And then 5i times negative I, well, 5 times negative 1 is negative 5, and I times I is I squared. Remember that I squared is the same as negative 1. So we'll have negative 6 plus 17i. And then negative 5 times negative 1 will give us positive 5. Negative 1 plus 17i when we combine our like terms, making sure the real part comes first and the imaginary part comes second. Now, a special set of complex numbers that you multiply together are what are called conjugates. Conjugates are when you have the same thing, but just the middle sign is different. And let's see what happens when we multiply our conjugates. 3 times 3 will give us 9. 3 times negative 2i will give us negative 6i. Now we'll do 2i times 3i to give us positive 6i. And then 2i times negative 2i will give us negative 4i squared. Well, the key thing to notice with conjugates is notice those middle terms add to 0. Negative 6i and positive 6i, those are now 0 and they're gone. Remember, I squared is negative 1. Negative 4 times negative 1 is positive 4, so we just get 13 back. So when you multiply conjugates, you should end up with a real number, okay? Not a complex number. Complex number means part real, part imaginary. We should get just a real number back when you multiply conjugates together. This next example is also conjugates because it's the same thing with just the middle sign switched. So negative 5 times negative 5 will give us 25. Negative 5 times I will give us negative 5i. Negative times a negative for the negative I and negative 5 will give us a plus 5i. And lastly, negative I times I will give us negative I squared. Negative 5i plus 5i, those add to 0. I squared is negative 1, so this is really minus a negative 1, which is positive 1. So we have 25 plus 1 to give us 26. All right, a really common thing that is asked on the Regents is average rate of change. When you see the phrase average rate of change, you need to think slope. When we do a slope, m is often used to represent slope, but we just do y2 minus y1 over x2 minus x1. Well, they will always give you an interval in the question. Our interval here is going from 4 to 11. And what that is those are the x values. So we're going to write those on as the first part of our points. And then we're going to go to our calculators. And we're going to go to a graphs page. And on that graphs page, we're going to put in our equation. We've got the square root of x plus 5. Then make sure you hit the right arrow to get out of the square root. Don't hit the down arrow, hit the right arrow, and then minus 6. And hit enter. And then we want to know what y values go with 4 and 11. So we're going to go to the table. We'll do Control T. Well, at 4, we have negative 3. And if we go down to 11, we have negative 2. So we'll go back to our points. And at 4, we have negative 3. And at 11, we have negative 2. So we'll just do our change in y over change in x now. So I'm going to start with negative 3 minus, now we'll have the other y value, negative 2, over. We started with negative 3, so we got to start with its x value on the bottom. So 4 minus 11. Well, minus a minus becomes a plus. Negative 3 plus 2 gives us negative 1. And then 4 minus 11 will give us negative 7. But a negative divided by a negative is a positive, so this becomes just 1/7. And that's what you do anytime they ask for average rate of change. Very likely that on the Regents in January, you will end up seeing one question like that. So look at one more example of that. We see average rate of change. We want to think slope. Look for your interval. We're going 1 to 16, so our points are going to be 1 comma something and 16 comma something. So we need to do square root of x and then a minus 5 afterwards. So if we go to our calculator, we'll add a new graphs page. We'll do square root of x, hit the right arrow, and then minus 5. And we were looking for 1 and 16. So we'll do Control T. At 1, we've got negative 4. And we'll go a ways down to 16, where we have negative 1. So negative 4 and negative 1 were our two y values. Well, now that we have our points, we can just do our slope. We'll do y2 minus y1 over x2 minus x1. So one y value is negative 4 minus, and then the negative 1 over, since we started with negative 4, we got to start with 1 in the denominator, minus the 16. Minus becomes a plus. Negative 4 plus 1 is negative 3. 1 minus 16 gives us negative 15. A negative divided by a negative will be a positive, and 3/15 reduces to just 1/5. So that is our average rate of change on that interval. So our next topic is transformations. So what we have here on the left in the table are the function notation of our transformation. In the chart, we're going to write what it would be in words and then what the equation would look like for each of them. So if you have something added on the end of your function, that makes it go up. So this would just be up 5. Well, this is saying take your function and then just tack a plus 5 on the end. So we would have y equals x squared, and we'd tack a plus 5 on the end. For the square root of x, we would take our y equals square root of x and tack a, oops, that should be an x in there, and tack a plus 5 on the end. And for the absolute value one, we'd have absolute value, tack a plus 5 on the end. So for those specific equations, those are all showing shifts up 5. Well, minus 3 on the end, that's causing the graph to go down 3. And what that function notation is saying take your function and just tack a minus 3 on the end. So for the x squared, we'll have y equals x squared with a minus 3 on the end. For the square root of x, we'll have y equals square root of x and tack the minus 3 on the end. And likewise for the absolute value, we'll have absolute value and tack the minus 3 on the end. So in f of x plus 2, that means anywhere there's an x, we're going to replace it with x plus 2 in the equation. But the movement it causes, it's opposite of what you would think. The plus 2 on the inside really makes it go left 2. So what we'll have is we'll have y equals, and then instead of having x being squared, we will now have x plus 2 being squared. Because x plus 2 replaces wherever the x was. And we'll have y equals, and instead of x having the square root done to it, we'll have x plus 2 having the square root done to it. And then lastly for that row, instead of x being having an absolute value, we'll have x plus 2 to have the absolute value taken of it. The next one's going to be pretty similar. The only difference is if you have a minus, again, it's opposite of what you would think it goes right for. So inside the parentheses is opposite of what you would think. Outside the parentheses is exactly what you would think. So these are very similar. We'll have y equals x minus 4 in parentheses all squared. Y equals absolute value of x minus 4. Or sorry, square root of x minus 4. And then the last one is y equals absolute value of x minus 4. So the next one, we're negating the x. So I want to draw a picture. Let's say we had the point 2, 1. Well, if you negate the x value, that would make it be negative 2, 1. Well, negative 2, 1 is now over here. If we went from 2, 1 to negative 2, 1, what that caused is a reflection over the y-axis. So if you negate the x, it reflects over the opposite axis. It reflects over the y-axis. So this is reflect over y-axis. And it's just like the last two that we did. The x is getting replaced with a negative x. And whenever you replace, you got to replace in parentheses. So instead of x being squared, we'll have negative x being squared. Instead of x having its square root taken, negative x will have its square root taken. And instead of x having the absolute value done to it, negative x will have the absolute value done to it. Well, our last one done in the chart, we're negating f of x, which is like negating y. So if we had that 2, 1 again, and we negated the y, that would give us 2, negative 1. So we would be down here. Well, we went over the x-axis this time. So if you negate the y, then you reflect over the x. Whichever one you negate, it always goes over the opposite axis. So this is saying whatever your function is, just put a minus out in front of it. So we're going to have y equals minus, and then x squared. So the difference between this one and the one before it is, in the blue one, the x gets negated first, then it gets squared. In the purple one, x gets squared first, and then it gets negated. So we'll have y equals minus, and then square root of x. Similar idea with the order of things that are done. The negation gets done second in all the purple ones. And then lastly, y equals minus, and then absolute value of x. So with our transformations down on the bottom, we're going to see if we can describe in words. So that first one there, we see the plus 2 on the end. So we want to see which one of our ones in the table up above also shows something happening on the end. And hopefully we see the very top row there, and that we are going up 2. In the second one, we got two things going on. We got a minus 2 on the inside and a plus 3 on the end. Well, you work inside out, so the minus 2 on the inside, that's similar to the fourth one down, so that's a right 2. And then the plus 3 on the end, just like we saw a second ago, would be a up 3. And the last one on this page, if you've got a plus 2 on the inside, that's exactly what we had in our chart, the third one down, that's just left 2. And if we go to the next page, this would be page 9, we want to write our equations based on the parent function. So shift down 3, we would want a minus 3 on the end. So square root of x, and then minus 3 on the end, not inside. If we reflect over the x-axis, that means we want to negate the y, so that would be out front, so minus, and then x squared. And if you shift left, you'll add to x. So we'll have y equals absolute value, x plus 5. Now we're going to do two more problems in the space you have on the bottom of page 9. So we're going to have you add them on there. Okay, and the first one is 5i times 3xi all squared. And the directions would just be to simplify. These tend to be the type of I questions that are on the Regents. And how I would suggest to write this is let's write it as 5i times 3xi times 3xi. And we're just going to multiply the like parts together. 5 times 3 is 15, times 3 is 45. X times x is x squared, and I times I times I is I cubed. Well, the I parts you can always punch in the calculator. So if we go to a calculator page, so Control Doc, add a calculator page, I is with the pi button. So we're going to do I raised to the third. And notice we get negative I back. And that makes sense because I squared is negative 1, and then times another I, so that'd be negative I. So this becomes 45x squared times negative I. Well, that's like it's a negative 1. Negative 1 times 45 is negative 45 x squared I. And that would be the simplified version of that question. Ones like that have showed up on the Regents several times. And then our last one for this video will have you add on 3x plus I times x minus 2i. And we're going to FOIL this out. 3x times x will give us 3x squared. 3x times 2i will give us negative 6xi. I times x will give us positive 1xi. Notice how I kept my x's and i's in the same order. That makes it easier to identify like terms to combine. And then positive 1i times negative 2i. Well, 1 times negative 2 is negative 2, and I times I is I squared. Keep in mind this I is really a negative 1. So we're going to have 3x squared minus 6xi plus 1xi will give us minus 5xi. And then negative 1 times negative 2 will give us a 2. Now the last thing is they usually want it in a plus bi form, so usually your I thing should come last. So we're just going to write it as 3x squared plus 2, and then minus 5xi. And then that would be it. That would be our simplified form. So you have packet page 10 for homework, the next page, which should be pretty similar problems to the ones we've just done. Have a great rest of your day.